as you just talked about, you have hydrology, you have hydraulics. In a straightforward design, you can use WWHM in Western Washington, design your facility. If you're doing pipe sizing, you then have to do single event pipe sizing in another program to determine if the pipes you design are the correct size. Up and down the West Coast, we have over a dozen versions of our software. They all have different criteria, and people have to use different models to achieve the same thing. Most of it is based on either SWM, some form of a SCS computation, or HSPF, and that's just the West Coast. Go across the country, almost all of it's single event at that point. People are using SWM or some other method to produce their event flows. Mark just got done talking about in Portland, where they were talking about the 50-year event or 25-year event. And obviously in HSPF, we don't deal with those events, we deal with continuous flow. And so Western Washington, no matter where you're at, you have a different approach for doing this. So you have hydraulics, you have hydrology, and what you really need is some way to do both well. HSPF is great at hydrology, SWM is not so great at hydrology. HSPF doesn't have hydraulics, really. SWM is great at hydraulics. So that's what I'm talking about here. So with HSPF, you have one approach for hydrology, with SWM you have another. And what we want to do is take the best of both worlds and move HSPF and SWM together to give you both hydrology and hydraulics you can count on in one tool, so that you're not jumping from tool to tool when you do it. So obviously, if you want to do things like compute flow frequencies, show long-term hydrographs, you have to have continuous simulation. SWM offers continuous simulation, but it's really not that great in terms of its quality when you compare it to something like HSPF. This is a duration curve, and that just shows if you do a typical Western Washington run, you have 60 years of data, 15-minute data. So you have, for example, the blue curve there is your pre-developed flow between two flow ranges, and that's 1.6 million data points. So how do you analyze that? Well, one way you analyze it is through analyzing how often a flow is exceeded. And then in Western Washington, you're required to keep half the 2-year to the 50-year, you can't exceed it anymore, so then you don't produce any new erosive flows. Well, that's how you do the hydrology. You're not going to do that in SWM. That's not something that SWM really offers as an option. But you can do it in HSPF, or in this case, WWHM, to size your facility properly. This is just an example of a hydrograph or a peak value flow chart or whatever as an output for long-term runs. This is a network that includes, it's an example of the software that you have basins that are HSPF, just like WWHM, basically that's what it is. But this network here is EPA SWM. So you're able to merge the two into one software, run it, and get the great hydraulics of SWM with the reliable hydrology of HSPF. And down at the bottom here, you can even size your pond, but you have the flow network that your site has. But sometimes existing flow networks are part of your design, or if you're doing a municipal project, it's almost always the existing infrastructure that's there. You need to model it in order to do whatever, include your green infrastructure, include your facility, your regional facility, whatever, has to be all in one model. And if you can only do it in either HSPF or SWM, you're not going to get the answers you want. First of all, if you're using SWM to do facility design, you can't even get that approved. You have to do continuous HSPF to get the facility design, but then you have this hydraulics in the meantime. And most people run HSPF, take an output for a week or so, and then use that to stick into SWM and get a hydraulic result. And that just gives you a little window. That 7 days, it's not really the same as running it for 60 years and finding out how this thing is going to perform for all the whole range of events. So merging the two is really the best of both worlds.